Good morning, good afternoon, good evening, wherever in the world you are. Welcome to our webinar, Don't Let Latency Slow Down Your AI Model Training with Lightbits and Supermicro. Today, we'll talk about common AI infrastructure pitfalls to avoid and the impact of low latency and high performance on GPU utilization and model performance. And we'll give you some practical tips for improving your infrastructure efficiency for AI. I'm Janet LaFleur, Director of Product Marketing at Lightbits, and I'm pleased to be here today with Sagi Volkov, our Distinguished Performance Architect here at Lightbits. Sagi is an expert on building infrastructure for large-scale environments, large-scale databases, compute, storage, networking, and more. We also have Wendell Wengen, Director of Storage Market Development at Supermicro. Wendell is a published author and conference speaker in AI cloud and enterprise solutions. And as you might expect from his title, he has deep storage experience. We also have Sherry Lynn, product manager for storage solutions at Supermicro, and she also oversees the product marketing initiatives. And as you'll see later in our webinar, Sherry is hands-on in validating solutions with the Supermicro partners like Lightbits. So we have a full agenda today for you, and we're going to answer all the critical questions. We'll start with a short roundtable discussion about the most common AI infrastructure decisions you'll need to make and those pitfalls to avoid. Then we'll dive into how decisions about storage, in a particular block storage, can accelerate your model training, your RAG, and more within the AI workflows that you have, and how you can choose the right solution to maximize your efficiency and minimize costs. Then we'll take a few moments to detail how a combined Lightbits software-defined storage and Supermicro hardware solution provide a powerful data platform for AI. Finally, we'll share a few stories of customers who built their AI clouds with Lightbits and Supermicro together, why, how they did it, and how it delivered business value to their business. We'll end with a Q&A session, so feel free to type any questions you have in that chat. On the right-hand side of your BrightTalk window, there's a little question mark. So that's how you ask your questions and start thinking about them now. So let's get started with the most basic question. What are the common pitfalls in AI, IT infrastructure for AI? So we're going to get everybody on screen here. So we'll start with the question for Wendell.
Yeah, yes. I can go. And I think the most common one that we really hear about, and of course, Supermicro is, a big leader in AI infrastructure. And, we have a lot of server products, including a lot of GPU accelerated servers. But I think in the context of what we're talking about here, which is really storage for AI, I think the biggest pitfall, that we hear about is really underinvestment in the storage infrastructure after companies and people who are spending a lot of money on all the GPU infrastructure, and networking, and really underinvesting in the storage, and that really affects the performance of their GPU cluster, the utilization of it, and it's really, I think, penny wise and pound foolish.
Well, thank you. Yeah. Is there, I know a lot of people are just focused on the GPU, and I'm glad you're bringing up the storage aspect. Are there any other aspects that you think are critical to success that people aren't thinking about these days that they should be?
Well, I think another one is just really about needing to, for enterprises that are looking to implement AI solutions in their products and in their infrastructure, that they really need a lot of data to train those proprietary models, their enterprise-specific models. And so I think, deciding to start collecting all your data right when you're implementing your model is probably, a little late, right? Mm-hmm. And you really should have been thinking about this several years prior to that, collecting, various data sets that you then can apply towards training your model. So I think that's just another, something you ought to keep in mind. And if you're not doing it now, I would really suggest start collecting things, even if you don't have an immediate need for it. You may have some idea in the future of some kind of an AI service that could really benefit from being trained with that type of data and that data set. So it's
Yeah.
really hard to predict in the future what's going to be useful. So I think
Yeah, so save it now. So yeah. And we heard that. We're going to talk about Nebel, who's one of our joint customers for Supermicro and Lightbits. And they basically said that a lot of their customers, they're a cloud service provider, had been saving all this data and really weren't utilizing it. And so then they built an AI cloud to be able to do that. Okay, so let's go to Sagi, who's from Lightbits. Wendell already started talking about storage. What are the typical storage architectures that are being used for AI today? And is that changing?
Yeah, so today we mostly see shared file system and also object storage that is being used to host the data.
Someone was detected at your front door ring.
Oh, well.
Not at my front door ring. Anyway, shared file system and object storage is where we see what we see very common today. And on the other side of this, a lot of usage for local or direct attached storage, a local NVMe or SSD attached into the servers. That's usually what you see today. What we are starting to see, folks are starting to understand, what we start to hear from our customers is that on one hand, object and shared file system are just not fast enough. And on the other hand, a local direct attached storage is limited and sometimes not consumed properly. And that's where we start to see block storage, specifically high-end performance like Lightbits coming into play.
Yes. It can be hard to predict how much you're going to need. And if you're already set in your local storage, people end up over provisioning for that reason. Yeah. Sherry, beyond the GPUs, how are AI servers and storage different from traditional enterprise servers and storage? What are you building differently at Supermicro for AI?
Yeah, so for AI storage, few point that we were seeing, like for AI servers, usually the CPU configuration, right? AI server use higher core count CPU, and for traditional those enterprise servers, usually just general purpose that is optimized for their business applications. So it's more focused on the balance and performance and cost. And the second thing is the memory. Usually for AI server, you require a large amount of high-speed memory, like DDR5 or like HBM, to handle those largest data set for training. While for traditional enterprise servers, usually just standard memories that you configure capacity based on the business applications. And the third one is an important one, that's networking, right? So AI servers mostly utilize those high-speed networking technology. For example, InfiniBand, NVLink, and higher than 100 gig Ethernet speed to facilitate data transfer between nodes. But for the traditional enterprise servers, usually it's just standard Ethernet networking, which is just adequate for their business use. And number 4 is the cooling and power requirements. So we know that AI servers, more higher power component were used in the AI server. So that requires, it will generate a lot of heat. So we will need better cooling and power system to handle those the heat and the power need. And for the AI storage versus traditional storage, the first one is the performance and throughput. AI storage usually is designed to support those high throughput for training and high IOPS and low latency for inferencing to handle those AI-driven workload. So high-speed SSD such as NVMe usually are used for AI storage. Or traditional enterprise storage, it's usually like looking for optimized for cost, performance, and capacity. So still like a mixing use of hard drive and SSD. And for scalability, which is an important one, like for AI storage, usually we have like so many GPU node in the AI compute clusters. but we will need the storage that is designed for parallel access to the storage so that it won't keep the GPU idle. Yeah, all the GPU will be busy all at all time. And for traditional enterprise storage, it really scale based on the business need, but not as the scale of AI storage.
Great. Okay, well, let's get started with our next question, which is for Sagi. How can block storage help to accelerate AI workflows?
So as we started to a little bit, touch some points where we see a lot of interaction with how block storage can affect I wouldn't call it the number one, but probably one of the most I would say recent cases is retrieval augmented generation, and which relates directly into all sorts of vector databases that are being used. And that's where we see a very high increase in demand for fast block storage. And I'll get more into details into that later on. Again, throughout the training process, inference, we see also use cases where block storage can chime in and help utilization and even a save in terms of the time it takes to do inference and training. So I'll discuss a little bit about Lightbits and how what is Lightbits and how Lightbits work. Lightbits is a software-defined storage, which means, first of all, that you have the freedom to choose whatever hardware platform you want to use. It is using NVMe over TCP. I'll discuss a little bit more about that later, but it's a protocol that Lightbits invented and is now part of the Linux community and the network community. And so you gather a few servers, you install a bunch of RPMs on them. All these servers have a local NVMe devices attached to them. And we basically aggregate all of these and create a storage platform for you to use. One of the unique things with the Lightbits is that we created our own flash translation layer, what we call the intelligent flash management, which basically enhance performance of the local NVMe devices that we use, and also utilize them in a much better way that it impacts the lifespan of these devices. It's a clustered solution, and all you need in order to access it is to have network with a TCP in it, which exists anywhere in any infrastructure. Let me dive a little bit about how we help AI modules. And so the first case in here, and this is really what we start to see in the last few months, kind of heating up, is RAG. And the way RAG works in general is by taking a look at some data, indexing the data in a very efficient manner. And when you are querying a vector database for that index, right now the assumption is that the index is, because you want it to be very fast, the assumption is that the index will sit in memory. The problem with that is that data grows, and a lot of the demos that you see today are really concentrating on textual stuff. But once you start to see data that comes from all sorts of visualizations, like images or videos, or even audio, like phone calls or things like that, data just keeps on growing and growing, and you cannot fit these indexes into memory. So some of the leaders in vector databases have already started to work on having indexes that basically can spill into the storage or resides entirely into storage. But in order to not impact the performance of the database and the queries that are being sent in the RAG process, it has to be a very fast storage, and that's where Lightbits come in. On top of that, even if you're thinking about using a local attached storage, you are then limited in size and you do not have any resiliency. So with Lightbits, you get the resiliency, also the freedom to move the data from a node to node. We see a lot of vector databases running in the Kubernetes domain, which is a very fluid environment, and pods are moving from worker nodes to worker nodes. And not using a host path or direct attached storage in Kubernetes is a big advantage, and that's what Lightbits brings. I'll move forward. So inference is a process that by this point, I guess everyone is aware in terms of once you do the training, you want to start to actually output something out of it. And again, throughout this process, we see the need more and more for fast storage and resilient storage in order to make sure that these processes are not failing and are able also to continue sometimes from the same places that they stopped. So this kind of summarize what you see a lot today in the AI domain. You see AI servers with locally attached NVMe devices. That's your left side of over the screen. And as I mentioned, you have a few issues with that. One is that usually the scheme is to dedicate an SSD per GPU, which means whatever you are storing on that SSD is limited by the size of that SSD. If you need something larger, you have to replace the SSD. Or if you, for some reason, you keep on using very small amount of data, you are underutilizing the capacity of the SSD. So using a fast storage like Lightbits, you attach our volume into the server, and the GPU can use that. You can make the decision whether the volume need to be big or small. So you never are not utilizing that volume. Furthermore, you might have throughout the process times where your local NVMe devices are just not used because the job is running somewhere else or on a different GPU. Again, once you do something like software-defined storage with NVMe over TCP with Lightbits, you can detach, attach to whatever you want the volume, so you never underperform or underutilize the NVMe devices. And of course, I've touched that as well. Resiliency is also something that we see more and more getting into these processes. And if you're using a local NVMe device, you basically have zero resiliency. With Lightbits, you can actually choose the number of replications per volume. So it can be one if you don't need one, or it can be 2 replicas or 3 replicas. All right, so just a little bit about NVMe over TCP. As I mentioned, Lightbits invented the protocol a few years back. It's been part of the Linux kernel since version 4.10, which means on any enterprise Linux version or flavor that you are running, it's already part of the kernel. You don't need to install or add anything in order to utilize a Lightbits storage or a Lightbits volume. And it's written in such a manner where there's high performance of parallelism of applications that are throwing and retrieving IOs into NVMe over TCP or into the NVMe flow. And Lightbits is pretty much one of the only software-defined storage solution that was written for NVMe over TCP. So we are able to use this parallelism to provide very high-end performance in terms of IOPS and throughput.
Okay. Let's talk with Supermicro about what they're providing in their hardware solutions to accelerate AI model training and more.
Yeah, thanks, Janet and Saigi. And I think that all of the really impressive software that Lightbits is providing, it really depends to get the most benefit out of it. Really depends on having the highest performance underlying hardware to run it on. And Supermicro has really the largest portfolio of server products that are both compute optimized and storage optimized, really, in the world. And here I'm talking about our storage optimized server products. And I know that Lightbits and Sherry's going to talk about in a minute or two some of the specific products that Lightbits runs on, including Petascale and some of our compute optimized server products. But I think in general, one of the things to really consider is in terms of your hardware performance, really having a balanced design. And what that means is having your PCI Express lanes that are connecting your NVMe drives to the CPU complex, and also your network I/O in a balanced design. So you have rear I/O for the network cards by 16 PCIe by 16 slots that you can support multiple NICs, up to now 400 and really moving to 800 gigabits a second. And then the front I/O that's really supporting your NVMe drives. And now we're moving with PCIe Express 5th generation, even higher performance. And we're starting to see that the NVMe suppliers of SSDs are moving to Gen 5 with very high capacities, up to 60 terabytes in some cases with QLC. So taking advantage of all that really high performance, allows software-defined storage like Lightbits to really shine. And let's go look at sort of the portfolio products. From the right side, I talked about Petascale, which is our flagship all-flash systems that have 1 or 2 Intel or AMD CPUs and up to 32 SSD bays in a 2U. We also have a 1U form factor. We have this high availability storage bridge bay product that's really designed for scale-up storage, which is also all-flash, up to 24 NVMe ports. And then moving towards the left are our disk products. So, those are lower performance, of course, with disk drives or hybrid disk and flash. Simply Double, very popular among service providers and hyperscalers for scale-out storage. And then our top-loading products that really give you a huge amount of capacity, over 2 petabytes per system with 90 3.5-inch disk bays. And then on the enterprise side, a smaller amount of disk capacity, but shallower built for the enterprise data center. So, kind of overlaying that onto the different use cases, and really what we're talking about here on the right side are applications that take advantage of that high performance. And of course, we have high performance block that we're talking about here. And, people also run parallel file systems, virtualization, databases, AI and ML performance workloads, and high performance computing. So lots of things that really take advantage of that flash performance. And on the left side, things that really, are more sort of less affected by latency and IOPS and more sensitive to cost, right? So object storage and backup and sort of traditional NAS applications on that end. So with that, kind of an overview of the different product portfolios, I think Sherry's going to talk about some of the specific products that we've been testing with Lightbits and what the performance numbers really look like.
Okay. Thanks, Wendell. Thanks, Janet and Sagi. Okay. So recently we have done a lab test with Lightbits solutions. So here you'll see there are 3 models that we have in this reference architecture table. On the left-hand side, the first one, you'll see the this portfolio is called basic densities, means that we have a 2U and 4 servers in one chassis. And in each servers that is support 6 Gen 5 NVMe drive. Okay. And this will provide you a minimum cluster node need in just one chassis. And in the center one, we have our petascale family, basic capacity with 8 drive and up to fully populated 16E3.S form factor drive. And on the right-hand side is also density models in between families, which support 2 servers in one chassis. Okay. And we'll show you some server overview. So this is a petascale servers. So the one that we tested with Lightbit is the Intel models, which supports dual socket Gen 4s or Gen 5s Intel CPU, and it support up to 32 DIMM slot. That's up to 8 terabyte DDR5 RAM and 2 M.2 slot for the boot drive. And in the front bay, we have support up to 16 E3.S form factor NVMe drive. And the rear side support up to 2 PCIe Gen 5 by 16 expansion slot for your network, and 1 dedicated LAN port, and 2 Gen 5 by 16 LLM slot, okay, for network need. And this is a petascale family, okay, in 1U form factor. And the next family is the between families. On the left-hand side, we have this 2U 4-node between. In each node, it support up to 2 M.2 slot for boot drive, and 2 socket 4s or Gen 5 Intel CPU, and up to 16 DIMM slot. That's up to 4 terabyte DDR5 RAM. And on the rear side, it support up to 2 PCIe Gen 5 by 16 low profile slot for the networking expansions, and 1 dedicated LAN port, and 1 by 16 Gen 5 LLM slot. So this is a 4-node dense model. And on the right-hand side, we have the between 2U 2-node models. Each node support 12 NVMe drive. And CPU M.2 and DIMM slot is pretty much the same as the 4-node. But in the rear side, it support 2 PCIe 5 by 8 LAN slot, and 1 PCIe Gen 5 by 16 slot, and 1 PCIe Gen 5 by 16 AIOM slot. So these are 2 family series that we have tested with the Lightbit. And I'm going to show you some numbers in our lab. Okay, so this is the lab result using the 232-core CPU, Sapphire Rapid CPU, and each node with 512 RAM. And we tested single instance in one server. Single instance means one Lightbit Light OS in one server, and dual instance means being 2 Light OS in one server. Okay, and with one instance we populate 8 drive, and 2 instance we fully populate with 16 drive. Okay, and we see this from the single instance we have up to, so a minimum cluster we with a resiliency replica 3 4 node, we can get up to 10 million IOPS for minimum clusters, and up to 81 bandwidth gigabyte per second for a minimum clusters. When we do the dual instance test, fully populate drive, one second, the performance increase to more than 67% with the read performance, 17 million IOPS for the minimum clusters, and up to 135 gigabyte per second for minimum clusters for read.
Just a couple of points on this. From Lightbit's perspective, from the software perspective, we support a minimum of 3 nodes. We always recommend customers that are going to use 3 replicas to start from 4 servers. and this is really the minimal clusters. Most of our customers are starting in a larger scale. Of course, a single server performance is completely linear to the cluster. So if a single server can provide you, for example, 4 million 4K reads, and you have 3 of them, you get 12 million from the cluster. If you have 10 of them, you get 40 million from the cluster. It's completely linear. And the difference between running the dual instance, just to emphasize that, and a single instance, it's just in a single instance, it's let's call it a more simpler deployment. There is one instance of our backend and frontend that is running on the server. In a dual instance setup, we basically utilize the 2 NUMA nodes in the server, and one instance of the software runs on one NUMA and the other on the other NUMA. And we, of course, as part of the cluster, make sure that data, replicated data, does not reside in a single server, physical server, even when we're using dual instances.
Okay. Yeah. Thanks, Sagi. Okay, so this is our lab result for the E3.S server, and the next one is our the density basic server between 2U4 node. So here we only do the single instance test with the cluster minimum with a 4 node cluster test. It has the up to 10 million 4K IOPS and up to 81 gigabyte per second for the 120K throughput. Okay. And the setup is pretty much the same. The only difference is with 6 NVMe drive per node and fully populated with this 24 NVMe drive slot between server. Okay. Okay, so that's my slide. Okay, back.
Okay. Yeah, so it's back to me. So I mentioned earlier that we had one joint customer that we were going to highlight, and that's Nebel. But we're going to talk more generally about how other cloud service providers are building their AI clouds with Lightbits and Supermicro together. So we've got 2 that we're featuring. The first one is called Crusoe, and if you watch 60 Minutes, you may have seen Crusoe being featured there. They are unique in that they're, or special in that their AI cloud service is being built out in locations where there's stranded energy. So they're, doing natural gas drilling, or they're doing wind power farms, and they can't use all the energy right there. So Crusoe comes in and brings a data center there to maximize not losing that energy. So they are offering an AI cloud to their customers that it's based on this stranded energy, and they're using Lightbits to provide external persistent block storage. And they also really value the data protection that we provide, especially for all the OS images for all their customers. So people are, running, they're stopping, they're coming back again later. It really creates a seamless environment for their customers now that they're using Lightbits. But what else it gave them is the performance of Lightbits was rivaling the local flash, which is giving them greater scalability. And the persistent storage is disaggregated from the compute resources. So it's not like a direct attached system where you have to predict how much you're going to need for each node. It's all disaggregated like a SAN would be. And of course, we're a clustered architecture, so that brings availability. And we also offer snapshotting, which makes everything more resilient, being able to recover quicker. And it's giving Crusoe efficiency and performance that helps them compete with hyperscalers, so that they can sell to customers who like the advantages that Crusoe bring. Oh, and that's my favorite quote from the product manager at Crusoe, is basically when they did the performance testing, they were really surprised how much Lightbits blew everything else out of the water with higher throughput and IOPS, as well as lower latency across the board. So the second one is Nebel. Now, Nebel is out of the Netherlands, and they are building an AI cloud for the EU because they have their own data sovereignty requirements there. And so a lot of people, enterprises in the EU, want to have their data remain on the continent. So they specifically looked to Lightbits because they knew they needed block storage for the range of AI databases that people are using, like vector databases. But beyond that, And then they also for the bare metal deployments as well. What they found is through their testing was that the fast scalable block storage that we provided them through Lightbits is enabling them to rival the AI clouds from the US-based hyperscalers so that they can compete 3 times performance for vector and their other NoSQL databases at 80% of the cost. Once again, they really value the enterprise data services with a 3-way replication. And also we have a quality of service, which is really important for service providers. You don't want a noisy neighbor stealing your cycles. And of course, like a lot of cloud service providers on the continent, and not just there, other parts of the world are also very sensitive to where their data is kept. So this gives enterprises in the EU an option that keeps their data more secure. So let's see. Just to summarize really quickly, I think Sagi covered this, but Lightbits is a software-defined cluster solution that runs on commodity storage, and it runs particularly well with Supermicro, and it's well tested. It's a clustered architecture, so it heals and scales itself easily. It uses standard NVMe SSDs. We don't do spinning disk. We are NVMe over TCP. When you run with Lightbits, you don't have to do anything. You don't have to have a special network. And what's more is your TCP IP network, it remains unchanged. You don't have to configure your NICs any funny way or set up anything with the network to run Lightbits there. We also provide what we call intelligent flash management, which is basically enterprise data services, the thin provisioning, the compression, snapshots, and thin clones that we mentioned, and all this built-in data protection that comes with that. And we also don't really require any proprietary software to be put on clients. So it makes it really easy to manage as well with a multi-tenant architecture. And so if you're a cloud service provider, you're really going to find that we provide everything you need to serve a number of different clients. Okay, we've had a few questions come in, but we have some more. So it's not too late to send them in. So just type in the question mark area on the right-hand side of your browser and we can get going. So there was one that came in that was related to performance. From Mark. What's the latency difference between GPU communications and storage? Is there a max threshold on storage latency that impacts GPU utilization? And I think it was Sagi who's going to answer this one.
No, I just gave an example of what we see, type of latency that we see in live production systems of Lightbits. To be honest, I don't know what is the maximum threshold of latency that the GPU require. Maybe someone from Supermicro knows that.
Yeah, but I mean, what I would just look at it more conceptually that GPUs have especially NVIDIA designs have a point-to-point interface or communications using NVLink and NVLink switching. So that's very high performance, getting higher every generation, and increasing with this next Blackwell generation. So that really provides a lot of connectivity between the GPUs, but then you still need that connection to the storage. And so I think just to elaborate on what Sage was saying, that the workload that the GPUs will be creating for the storage can be unpredictable, and there can be small blocks, large blocks, different combinations of read and write traffic, right? So I think it's pretty hard to really specify like what is the maximum latency. I think the goal here really is to decrease the latency as low as possible. That would prevent or minimize the amount of GPU stalling when, as you're talking about, you're not able to fit all of the model data into the working storage in the GPU cluster, right? So you have to pull data out of the shared storage environment into the local storage that's in the GPU cluster, which then gets loaded into the local HBM memory on the GPU itself. So I think there's this whole tiering going on. Having like the performance optimized on each stage of that tier is just really going to benefit you no matter what that what that workload looks like.
Mm-hmm. Yes. Okay, let's go on to another question. This one is asking, how does Lightbits compare to VAST? Sagi?
Well, Lightbits is a block, an only block storage solution. VAST started with kind of a mix of file and object. They might be adding a block as well. We are only and solely optimized on block storage. Big difference, and I hinted it a little bit, is that in order to really utilize NVMe over TCP to the max, and by that, for example, utilize a Supermicro server with fast CPU and fast NVMe devices, you really need the software-defined storage software to be written in order to use to the max NVMe over TCP. And that's Lightbits from the get-go was written to support only one protocol, which is NVMe over TCP. And that's why we're able to get to these massive amount of numbers of IOPS or large throughput. Hopefully that answered the question.
Yeah, I think that was good. Let's see. I've got two related to scales. To start with the most basic one. This one's for Supermicro. What are the SSD form factors and capacities supported by the petascale storage servers?
Okay, so for the petascales, we currently have up to 30 terabyte E3.S form factors for the petascale, and the current model that validated is 1U16 bay, up to 16 drive. But Supermicro also carried the 2U32 bay up to 32 E3.S form factors models. That if there's opportunities, feel free to reach out. We can always work with Lightbits to do the test on the server.
Mm-hmm. Yeah. And then the related question was for Lightbits is basically how much can Lightbits scale out or scale up?
Right now we support a cluster of 16 servers. It's a more of a logical limit that we have set. It's not an architectural limit. And we are going to start and support up to 64 servers in a cluster. In terms of a number of devices, I guess in a single server, I don't know if there's anything more than 24 NVMe devices. If there are chassis that support a lot more than that, but you also have to start to look into how you want your resiliency to look into. You want to have a dense server, but you also don't want to have all of your data or large chunk of the data in a single server. So scaling out with the many servers helps your resiliency and definitely helps your performance.
Great. Okay, so this one is right up Sagi's alley. It's about which AI databases does Lightbits support?
Well, the beauty about using a storage like Lightbits is that we provide a fast interface to a block storage. It is up to you however you want to use it with whatever database. In fact, with most of our customers, we don't even know what is running. A lot of them are looking at it as like an infinite chest of IOPS. So they just continue to add more and more applications and add more servers when they need more IOPS and throughput. We did have specifically for vector databases. We are doing some work with the Milvus and with the PG vector, which kind of, I guess, symbolize the two spectrums of how you look at vector databases today, whether it's a database that is specifically created to handle vector data, or in the case of PG vector, a regular SQL database like Postgres with an extension to interact with vector data. But in general, any database that you wish to work with the Lightbits will work for you.
Okay, I've got a new question coming in. It is for the IOPS bandwidth performance data you showed. How many network links were used between the server and Lightbits appliance, and what was the speed of those links? I believe this one is one that Sherry's going to answer.
Yes. Yeah. So for the one instance, we have one CX6 200 gig NIC per node. Yeah. So the speed, the link speed is 200 gig.
Okay, cool. Got a question for Sagi about replication and Lightbits. How does it work, or what kind of options do we offer at Lightbits?
Well, so actually, Lightbits offer call it a two ways replication. We on the server on a single target, let's call it. That's the right term. We offer elastic RAID, which is a local erasure coding mechanism that we use, which means that you can lose an SSD device and still have all your data available without any impact into the cluster behavior. At the cluster level, as I mentioned, when you create a volume, and you can do it because Lightbits was built for multi-tenancy, you can do it at the project level or at the volume level. You can decide whether you want to have 1, 2, or 3 replicas, and we will spread these copies of the volume into evenly into the cluster. Of course, we consistently look at utilization of the cluster in terms of capacity and how we spread the data, and we will do, if needed, rebalancing of the data in the background, which also is automatic and does not impact the application IOs. We always benefit or give advantage to application IOs versus to let's call it a Lightbits backend communication. And I think that's will have answered this question.
Yeah, that's great. Well, it looks like we've gone through all of our questions. Thank you to everyone who turned them in. And thank you to everyone for attending today. Oh, no, there was one more question. This one came from me, really. And it's for Wendell. It's like, how do you purchase Lightbits and Supermicro together?
Yeah, thanks, Shannon. So you can contact Supermicro. We resell Lightbits, which, and also the hardware that runs on there. I just add kind of one thing. I think that really some of the real huge benefits of Lightbits that we talked about it a little bit, but our GPU servers that have 8 GPUs that can be either air cooled and water cooled, they now have a fair amount of local NVMe storage in the chassis, like now up to 24 NVMe drives. Now, these drives, if they're being used for persistent storage, are not data protected. So they really need a data protection layer, whether it's local there. So I think Lightbits is a great way to provide that, and also providing that shared external storage that even with all that capacity, that's really not sufficient for the entire training sets. You're going to need to move data in and out. So I think that's that kind of shared storage that has all of the data management features that Janet and Sergey talked about is really important to having a very efficient utilization of those quite expensive GPUs.
Yes, you want to use them very wisely. Okay, so Once again, thank you all for attending today. But if you want more information, you can use the QR codes to read our AI solutions page, or you can schedule a meeting with Lightbits to see how it would work in your environment. Thank you for joining us, and good afternoon, good evening, and goodbye.
Thank you. Bye.